Hello, this is Dave from Device Doctors in Bloomfield, New Jersey. We're going to be going over replacing a charge port today. But before we start, I wanted to talk about these tools. We have the Wagner paint gun, we have the Baku rework station. There's a couple of training centers that use these tools. My recommendation is never use these tools. These are not quality tools to be using on any customer devices. We'll go over some of the rationale behind that. So for now, if you see any videos or training centers that tell you to heat your board with a paint stripper, I would say do not follow that advice. Anyway, so here we go. And we're going to start off with looking why this particular paint gun is not a good choice. Let's take a moment to discuss these tools and why these tools are inadequate for mobile device repair. The primary reason is because they're inconsistent. The amount of heat that's put out by these devices are unpredictable. There's no way to do repetitive repairs and have a constant success rate. The Baku device comes with a soldering iron. When both devices are on, they don't necessarily work consistently. Your soldering iron could be hot and you try to put the hot air and all of a sudden the hot air is not pulling enough heat. The Wagner is kind of like a nuclear blast to your board. It gives you 1,000 degrees and it's not controlled or focused. It's kind of all over the place. I can demonstrate that with a thermal label in a couple seconds. Let me do that real quick. If we take a label and put it down over here, actually let me just put it and try to center this label. We can use a screwdriver or something to try to get an idea of its aim. Let's mark it as an X of what looks like the center and try to apply heat to it. Try to aim it. Let's put it in within approximately 3 inches as some training recommend. Oh, there it is, it's coming down. You can see the area that's receiving heat. While the X is in that circle, it's typically recommended that this go on for about 3 minutes in order to remove a charge port. Now let's look at that area to see how much of the board has actually been heated. If we take, let's say, a Samsung S3 and superimpose it over that X, you will notice that this chip, all of these components, there's usually a mic here, are all receiving heat that's unnecessary. From experience, I've found that using this tool setup, I get close to 30 to 40% failure rate. I was going to say success rate, failure rate. So my success rate is 60 to 70%. When I moved away from this technique and I moved to better equipment using low melt alloy to remove it as opposed to heat, my success rate went up to almost 100%. I rarely have any issues with a charge port, and even if I do have an issue, it's usually repairable. Using these tools, you're more likely to damage a board than actually repair it. So just to continue, in some of these help videos online or in some of the training centers that claim to teach you mobile device repair, there's a technique called hot swapping where they will put the board 3 inches away from a Wagner heat gun, wrap the board in Captain tape, put some heat shields on it, drop some flux, heat it up for 3 minutes, which from my experience I've seen it actually warp a board and then attempt to replace the charge port while the board is hot. And then you inspect under a microscope, and it's not a microscope like the one that you can see here in the perimeter. It's more like a high school microscope, which I'll add one to the video later so you can see what I'm talking about. Again, these are equipment that, yes, you can survive with, but if you can avoid, I would recommend never using in phone repair. You have more of a likelihood of damaging the device than repairing it. What I'm going to demonstrate is how to remove a charge port without using hot air, using the low melt alloy without exposing the board to unnecessary heat. So we're going to cut, and we'll come back to that in a couple seconds. Okay, so when we left off, I was going to show you how to solder, I just say desolder or remove the charge port without using hot air. I dug up an S3 board. This is an original port, and the charge port actually still works. It's a little beat up, but I wanted to use an S3 that had the original port so that we would be dealing with a non-lead solder that usually requires a lot of heat to remove it. What we're going to do is we're going to use ChipQuick. And ChipQuick has a product for removal of SMD components. So it's a low melt solder. And we're going to add, since we actually have a stick right here, we're going to add some solder. So grabbing some flux, and I'm going to flux this port. And notice I have no Kapton tape, no heat shielding, nothing to protect the board, because I'm not blasting the board with a paint peeler. I'm going to grab the low melt solder, and I'm going to apply it along the pins, make sure that it gets absorbed in here. There we go, it's grabbing on nicely. And this is going to make that solder really give. So I've applied enough to the pins. Now I'm going to hit the anchors. A couple seconds, I'm going to put a little bit more flux. I'm liberal with the flux, especially when removing. And we're going to put a little bit over here and let it soak into that. And you'll see it actually soak in to the anchor. I'm going to drag this up, see if I can drag some of it over here, bring it down to the bottom corner. I normally have a fume extractor going, but it would make too much noise and you guys wouldn't be able to hear me. So I'll sacrifice my health a little bit while I do this video. And let's do the other side. There seems to be some flux there, but yep, we got. And we'll do the last one up here. We want to get that to soak in to that anchor. This may look a little messy, but we haven't applied any hot air. We're not risking reflowing the BGA unnecessarily. If I see that this is not giving, we'll turn it around. But it seems already like it's already giving actually. So now while I'm doing this, let me just grab any tweezers. Here's a tweezer. Just going to grab the tweezer. I'm going to keep heating up the charge port with soldering iron, and boom. I'm going to clean this off with a wick in a second. So I'm going to add a little bit of flux. Put it across. Grab a wick. This is a thin wick I grabbed, but this will be okay for the pins. Let's see what these things look like. I'm going to grab a thicker wick to get rid of those holes real quick. Let's see. Here we go. This is what we're looking for. So, with the existing fluxes there, it's probably enough. I'm just going to grab this and apply some heat for a couple seconds right into the anchor hole. And just slowly pull on the wick. And remember, this was lead-free solder. That's stuff that you need to put 1,000 degrees of heat on it. I'm going to just grab a Q-tip, a little bit of isopropyl alcohol. And this is 99.5% proof. I don't use like stuff you get at the pharmacy or anything like that. You can get this stuff on Amazon. Order it by the gallon. And there you go. You got a removal without any hot air, without risking the board. And you pretty much will have like 100% success rate once you get this technique down. Okay, so this is the port we removed. I stepped away and I got a replacement port that we're going to put up now. And we got to put it in the right direction. So we're going to stick this guy in right here. Okay. The pins don't seem to be, the port's sitting pretty flat. Yeah, that looks okay actually. So we're going to solder on a new port. Let's have some fun with this, and we're going to purposely, well, as we go through it, I'm going to make some purposeful mistakes and show you how to correct them. Might as well have some fun while we're at it. So I'm going to pin down one of these anchors first. Let's grab a little bit of solder. And I'm going to put a little bit on the tip, which is not typically a good technique, but I'm going to do that so that I can hold the port flat while I start to anchor it down, because I want to make sure the port is flat to the board. This is one of my larger tips without changing tips. It's doing an okay job, but it's struggling. And that's because of the thermal mass. That's a big ground plate that we're trying to heat up. But that'll hold the port in place there. We're gonna pin down the other side also. Let's pin that guy down. Okay. I'm gonna put a little bit of solder in there. Struggling to generate enough heat, but that's okay. There we go. Let me get the tweezer, press down, see if I get the solder to flow. Yeah, that'll hold. And we can revisit it once we get the pins down and the other anchors down. Now, when doing these pins, they're pretty close together, so there's a good opportunity for bridging here. Now, you can do this a variety of different ways, and it's really a matter of preference. I'm going to turn on my other soldering tips. I'm going to use a micro pencil to demonstrate one. So we're going to start off, let's just grab a little bit of solder, stick it on the pad and the pin. When the solder flows, it'll go up the pin a little bit. Let's see what we got going on here. Get it onto the pad. So there we go. That's one way of doing it. That looks pretty good. Another way of doing it is using a tweezer. And I tend to do a similar thing with the tweezer. Bring the tweezer together. I'm going to change the angle of this, being a lefty and all. I could put a little bit down on the tweezer, and then I can kind of just stroke the pin. I come from one end of the pin, I let it open up, grab the pad, kind of stroke it in, press down, make sure there's heat in there. There's not enough flux going on here, so let's there's not enough heat going on here. I'm surprised it's flowing at all. Here we go. Let's do that again. Now, because of the heat, it'll pull the solder, so we're not going to worry about that. There we go. Cut that. That's good. So that's another possibility. Another way you can do it, so that was using the micro pencil, using the tweezer. I'm going to grab the next set of pins over here, put a little bit of flux. Now I'm going to grab a larger tip that has no business here, but why not? We're going to grab some flux, some solder, put it on the tip, and just kind of bring it across. So we have some bridging there. I'm going to clean the tip. Now this tip is pretty large, so I should be able to basically just suck the solder away with a few attempts without even wicking. There we go. So that's done with a larger tip. If you increase the thermal mass, the amount of heat, the solder will be drawn to the heat. So you can clear bridging without having any issues. Now that bridging on the Samsung, you notice these three pins, these guys are really close together. Here's where you're really going to have bridging issues and difficulty separating them. So even with the micro pencil, so let's play with the micro pencil. Let's purposely mess with this over here. Let's grab some solder. Let's try to get it to stick. Get it to stick. Oh my God, we bridged it. And this is going to be frustrating. Again, when you grab a larger tip and you introduce it and kind of move it away, you're going to start clearing that up. It's not really budging on that first stroke. I took it away because I want to add a little bit of flux to it. That's a lot of flux to it. We grab the tweezer and pull some of that away. So here we go. And now we're going to just kind of drag that solder away. We're going to down, clean the tip. It may take 2 or 3 tries. This one is a little tougher because the tips are so close together. But that's okay. I think we already got one of the pins pretty much clear. Do it again. That guy's probably sticking, but I'll show you that this will take it off. can always go back to the tweezers. We'll also do it. But I think we're looking at flux. So let's get a closer look at this. Let's see if we can zoom in. Let's center this here. Let's zoom in. Let's see if we can get this clear. I'm gonna have to change this. Okay. There we go. So now I'm gonna stick with the large tip, because this is a common problem that can be frustrating, is bridging. So I'm just going back and forth, removing the solder. Oh, that looks like I can spread it more, but it's already, you see the heat. And this is a good experience, because this is kind of what you kind of end up with when you bridge these pins together. And you're going to find this in things that are close together, but you don't have to go crazy with it or redo it. You just patiently use a bigger tip. And I can approach this with a larger tip, and it would probably do it much faster. I could put a wick to it if I get frustrated, or I can use a tweezer tip, which we may end up doing. But I'm having mixed success here, so I'm trying to do it just with this tip, pretending I don't have the others. There we go. We just unbridged that. Now we just have these two that are bridged. Just gonna pull them. And this is good, because this is a real world frustration when you're having this stuff. The solder's not flowing the way you want it to, it's not sticking to the tip. I would just add more flux when I'm having this. I'm gonna do a couple tips. The question is, what's gonna break first? Me with this tip, or me going to the tweezer? Okay, this guy's being difficult. So I'm gonna, before I change tools, I'm gonna just use the wick to back it off, a very thin wick. Put it in, just gonna grab this wick and just put it there for a second, and boom, it's clear. So that's one way. The other way, which is again using the thermal mass, would have been to use this tweezer, which I was trying not to do because it's kind of cheating, and where you can kind of stick this tweezer in between the pins like this and just kind of pull the solder away. Actually, I caused the bridging there, so let me show you now with the tweezer. I find that depending on the situation, you can use multiple techniques, but this is good. I'm going to clean the tip. The tip had some solder on it, that's why I caused the bridging. So I'm cleaning the tip off some more, and then I'm just going to see how many wipes it gives me. 1, 2, and the other one bridged. Almost got you off of there. Fun with bridging. And all of this stuff Just screw it up the solder a little bit, but there we go. So there we go. These are all pins. Let's zoom out a little bit. We didn't do the last two. So these are all different things that you can do when messing with these pins, dealing with bridging. Very common issues. Let me move this up so you guys can see it. The last two pins over here at the bottom that were not soldered in. I'm just going to use a tweezer. I'm going to put that in. I'm just going to one, two. Oh, look at that. Another bridge. I'm going to take this one off quickly. Seems like the most effective way today was with the wick, so we're not going to spend more time. I think we covered bridging. I'm using a dirty wick, but that's okay. That should be enough just to clear this up. Oh, there we go. I can use the micro pencil. So I mean, having the right tools gives you options. But you can see why your success rate would be basically 100% because you wouldn't be running into any issues. This pin is a little off. I can actually use the micro pencil to kind of try to move it over a little. Oops, actually that was a little too much, but there we go. Let's see. Let's grab a tweezer. Let's just use it with these pins. These pins are in. They're not moving. They're not moving. They're solid. So they're attached to the board. They're not going anywhere. And that's basically it. I mean, we can do the other anchors, but I think that's self-explanatory. So that's basically changing a charge port. The importance of using the right tools. If you guys have any questions, you can reach us at devicedoctors.com. We're going to be posting more videos, so we hope to hear from you.